Okay, so let's take a look at question number 2 now. Question number 2, I think, is an interesting question. We're asked to write the implementation, or at least partial implementation, for class username. So class username has one instance field, which is an array list of possible names. So it's an array list of strings, I should say, named possible names. Looks like we're going to write the constructor and then a function called set available usernames. Now, I guess the whole gist of this is you would call or try to implement or instantiate, boy, that's a good word, that's the right word, an instance of this class. When you do so, you pass it two strings, a first name and a last name, and then it's going to construct an array list of possible usernames from this first and last name, where you're always using the complete last name, but then you're just I guess taking the first letter of the first name, then the first two, then the first three, then the first four, and so on and so forth until you've reached the end of your first name string. All right, so this is interesting. All right, so let's move over to the answer and we'll talk about the answer. So first point is you construct possible names array lists, and I've mentioned this before, I know, in class, but this is something that is so easy, and yet whenever I've graded questions that ask students to do something like this, I would say easily 90% of the students forget to do it. And I don't think it's because they don't know to. I think it's just because you forget. So the problem, I guess I should say, in the class itself, where's our class? Here it is. You can see that we're declaring the array list. However, we aren't instantiating it, right? So that's the first thing we need to do. We say possible names equals a new array list. And listen, if you have the left-hand side as well, so let's say you have something like array list string possible names equals a new array list, you're not actually instantiating the instance field. What you would be doing is declaring a new array list and instantiating it. But you have to have just the name of the array on the left. So you're saying the variable I've already declared is equal to a new array list. So that's 1 point, easiest point perhaps you could ever get, but again, an easy thing to forget. Okay, the second point is for generating substrings of all possible lengths in the context of a loop. So here, I think this would have to be a regular for loop. I mean, I probably could use a while loop, but that just wouldn't make much sense. But you can see we're starting at 0, and then we're continuing as long as we are less than the length of the string. Okay, so we're going to add, and that is important. We need to make sure that we're adding to the array list. This is an array list, so you have to use those array list functions. We're going to add a new string to it. Now you don't have to, I guess, explicitly construct a string, right? We know that strings are objects, but they're kind of unique in that you can just kind of set one, create one right in place as a string literal. But we're going to say last name, which is our last name string, plus first name as a substring starting at 0 and then continuing to I plus 1. So the first time through the loop, I is going to be 0. And so the length would be 1, and so on and so forth. Now this does, in my mind, raise kind of an interesting point because we're going to continue up to the length of our string, right? So let's say we were looking at the example that they gave, which was a first name of John. Yeah, right there, right? So John, I think we can see that the indexes of the string John are going to be 0, 1, 2, and 3. But the length is going to be 4, right? So the length would be 4 because there are 4 characters in the string. So we'll continue as long as it's less than. So in my mind, it goes up to what? 0, 1, 2, and 3, right? So those are the iterations for I. But we're going from 0 to I plus 1. So I guess what I'm trying to say in a very roundabout way is we're going to reach a point where we try to add a substring at 0, and the end index, so starting index 0, end index would be 4 because I goes up to 3. Obviously 3 plus 1 is 4. So we're going to have a substring from 0 to 4. 4 is out of bounds, right? If the string only goes up to 3, 0, 1, 2, 3, 4 is going to go out of bounds. Why is that okay? Well, hopefully you recall that our substring method of the string class, when you give it a starting index and an ending index, the starting index is inclusive. The ending index is exclusive, so it doesn't actually include the character at index 4, so it would go from 0 up to 3 inclusive. All right, so I guess the first iteration, maybe it's worth mentioning, it's going to go from what? The first parameter is going to be 0, the second parameter is going to be 1. It won't include the character at index 1. It would only do the character at index 0, which would be j, again, in our example data. Okay, so that was probably all the points, but let's just break down the points to make sure we have them all in place. So generate substring of all possible lengths. So that's this piece where you're going from 0 to length and then using the substring method. Generate a username in the correct format. So that's using substring as we're doing here, and then this string concatenation piece where you're adding last name to a substring of first name. And then the fourth point is adds possible usernames to possible names. So that's using the .add method. Okay, so there are the 4 points for writing our constructor. I know this is a bit out of the ordinary. We don't usually do much as far as algorithms inside of constructors. It seems like most of the examples I've always given you has just been really straightforward, where you're doing something like this, where you're initializing an object. But we often don't have much logic inside the constructor. So I hope that doesn't confuse you, because that is the sort of thing that they definitely like to ask you to do on the AP exam. All right. Now let's take a look at part B. In part B, we're writing the username method set available username. So this method's just going to iterate through our possible names array list and remove the names, or excuse me, a string in possible names if it already exists in used names. Okay, so we don't want to have any strings in possible names that is already in used names. Okay, they wrote a method for you called isUsed. IsUsed method searches for name in R. So basically, you don't have to check the strings for equality using .equals. I'm sure that you can, because it does not say that you have to use isUsed. No, I'm sorry, it does. It says you must use isUsed appropriately to receive full credit. So that's an important point, right? You might correctly check to see if a string is in both possible names and used names using .equals, but if you do not use isUsed, you would lose a point anyway. Okay, so let's look at their solution. 1 point for traversing all the possible names without a bounds error. All right, so you can see they're going to count down, and that's important, right? We know that when we remove things from an array list, we always want to start at the end, counting down, starting at size -1 and continuing as long as we're greater than or equal to 0. And the reason why we always want to count down is because if you're counting up, if you remove an item from the array list, it will skip the next element, right? Because index or I would continue to go up, but everything in the array list would kind of shift down. So you can see they're just saying if is used, passing it possible names at I, and then our array used names. So we're using that is used function. You could obviously have said equals equals true, but is used returns a Boolean, so there's no reason to do that. Right? So if it is used, then we're just going to remove it using the remove at I function. Okay, and they give you an alternative option where they are counting up and then just decrementing I, but I don't like that. Let's not do that. Let's just do it the best way, which is simply to count down, because it's not difficult to do. So that's the canonical solution. I think that's about it. Thank you.